Hello, everybody, and welcome to What's Up, the podcast where we talk about everything electrical and the future of test and measurement. My name is Darcy, and we're here to delve deep into some of the biggest topics in our industry. Today, we are talking to Dr. Ahmed El-Rashid, whose work has seen him travel the globe, working in such roles as design engineer all the way to business development director. Today, we are discussing one of the fundamentals of asset management, which is insulation testing. So let's find out what's up with Dr. Ahmed El-Rashid. How are you doing today, Ahmed?
I'm doing very well. Thank you for having me.
No, absolute pleasure to have you. So we usually start the podcast with something we call the power up. It's to get our creative and our brains going. So are you ready
Excellent.
for those?
Yeah, let's do it.
Perfect. So I'm going to ask you 3 questions. And the first one is, how long have you been in the test and measurement industry?
14 years now. Worked in various different positions, applications engineer, design engineer, and now my position is Director of Business Development.
Amazing. And what was the last industry standard you worked on?
I'm in the committee and currently working on the IEC standard 61557, which
sounds so catchy.
It governs the installation, low voltage installation in like houses and commercial settings, stuff like that.
Great. And what applications are you currently most interested in?
Here in the current climate, the electrical industry, the renewable sector is very exciting. There's a lot of investment and development and lots of new technology coming in. It's very, very interesting.
It's the one to be in at the moment, isn't it, right?
Absolutely.
For sure. Okay, well, let's get straight into it then. Insulation testing, it's fundamental to kind of test and measurement. You know, everybody pretty much thinks they know what it is, but kind of in your knowledge, explain to us what it actually is.
Right. So insulation testing, I tend to always refer to an analogy to try to kind of describe it.
Yeah.
People in the electric industry might, find it a bit reductive, but it's really useful.
It's an easy way to get your point across. So.
Absolutely. I take a look at insulation like looking at a garden hose where you want to like water the lawn or something. The garden hose, it's a conduit to flow water from one point to the point where you want it.
Sure.
Insulation is wrapped around the conductive part of an electrical circuit, and you're just trying to guide or make sure the electricity flows from where you're generating it to where you want to use it. Insulation testing is checking that insulation around it is intact. So, for example, with a garden hose, if you've got multiple garden hoses and you want to use one, but you know that one of them has got a hole in it, a small prick in it.
Yeah.
How would you know which one is the one that's got the problem? The best way to do it is to plug it into the water and run some water through it, but with enough pressure that you'll spring a leak.
You can see where the leak is.
And you can see where the leak is. It's a similar principle with insulation testing. We put pressure in terms of electrical pressure, which measured in voltage, push that through the insulation, and if it holds steady, the pressure holds, then you know the insulation is good. If it's not, if it drops or it wavers, then you know there's a hole in there somewhere, there's leakage in there somewhere.
Sure. So there must be a huge benefit then to adding insulation testing to like a maintenance schedule.
Absolutely. Referring again to the garden hose analogy, if you don't keep an eye on where you've got the leak in your hose, you can have water where you don't want it, and you have pooling of water. The problem with having that in electricity is more violent than the water.
Just a garden hose and some water.
So if electricity is leaking out where it shouldn't, that could very easily be a cause of an electrical fire. So it's very, very important to maintain good insulation and double check that it's always good.
Absolutely. So I get the impression that obviously insulation testing is paramount for safety. So what are the consequences of maybe like not doing it?
Well, it's best illustrated with some stories. One of them that I was involved with personally, where I live in Toronto, there's a building company that is in charge of building 300 new housing units, and they were, going real fast, trying to finish the job on
Get it
time.
done.
And they finished maybe like 80 houses out of the 300. And one of the technicians who was working on the cabling that goes behind the wall, where all your plugs come out of those cabling, he was stripping one of them back to plug it in, and he realized that one of the wires in there didn't have any insulation around it whatsoever.
Wow, okay.
So they all got in a bit of a panic because obviously no insulation around one of the wires. It's in the walls. This is an electric fire waiting to happen, yeah. So their problem was that they didn't do acceptance testing. When you get the raw material, the cabling from the manufacturer, you need to do some acceptance testing, which is an insulation test. And then you accept it. Otherwise, you have to reject it, send it back saying this is faulty.
Yeah, not suitable.
So we helped them testing the within the 80 houses that they already finished, and we found in 24 of them that problem was there.
Wow, that's
and they
huge, isn't it?
Yeah, they had to gut it out and replace all the wire. So the consequences can be pretty bad.
Yeah, I was going to say it has massive implications, really, doesn't it?
Absolutely.
But what about the actual testing itself? Like, what are the safety implications when it comes to that?
Yes. So obviously, one of the concerns about when you're doing insulation testing is that pressure of electricity that we're forcing through in order to discover where the insulation weakness is. Normally, you want to test with a voltage higher than what the insulation under normal conditions would be subjected to.
Sure.
So if something is supposed to be running at, let's say, 250 volts, 240 volts, you want to be testing it with like 500 volts.
Okay.
So you're dealing with a higher voltage, and that in itself has some safety implications to the user who's actually doing the testing.
Yeah. So
it's important to use instruments that have been designed with safety in mind, so that when you're touching the instrument and there's something going wrong, you don't get electrocuted.
Yeah, you don't get the shock.
And what's equally important is using the right PPE, personal protective equipment, the right insulated gloves, insulated boots, so that if there's something going wrong, you don't become part of the electric circuit and get shocked through. I've got a few stories about that. I can share one of you just to kind of illustrate.
Yeah, that'd be great.
We had one customer in the U.S., and he was testing a substation, part of just standard maintenance testing. And with an electrical substation, in many cases, they shut down only one part and do testing on it, while the other part is running to keep supplying the neighborhood that it's supplying.
Yeah.
So he goes inside in a substation. There's like a house, what looks like a little house or hut in the middle. Mm-hmm. So he went inside to do his testing, and on the wall there's multiple bus bars, and you got to test the different insulation assets to the bus bar. But he connected to the asset, and he was about to connect to the bus bar, but he connected to the wrong bus bar by mistake, the one that was live.
Wow.
And he was subjected to quite a lot of voltage, multiple thousands of volts. Unfortunately, he wasn't wearing his PPE, and he got secondhand degree burns on his hand.
Ooh.
So while doing testing, it's very important to use the right equipment, to have all the correct PPE, wearing it all the time, and just to ensure that just in case something goes wrong, a mistake is made, people are safe.
Yeah, that's crazy, isn't it? Like, the implications of not doing this can be absolutely huge. And I think a lot of doing it successfully means you have to rely on having the right data. So how would people know that they're getting the right results?
Right. So when testing insulation, any type of insulation, the best source of knowing how to test it and what is a good result or what is a bad result is to go to the manufacturer of that electrical asset, whether it's a cable or a transformer or whatever it is. The manufacturer should tell you, our product tested with this much voltage, and this is the kind of resistance you would expect to see.
Yeah. So they can help guide you in what's going to be best.
Now, not all the time do you get that kind of information from the manufacturer. And what we do when I sit in standards committees is we try to help people by giving them general principles to look for. So, for example, There's a NETA, which is the International Electrical Test Authority. It's headquartered in the U.S. They've published some recommendations. So they'll say if the standard operating voltage is this, then test with this voltage, and you're expecting to see a minimum amount of resistance of this. So that is my kind of recommendation. Either go to the manufacturer, follow their recommendations for testing, or go to the standards and follow those recommendations.
So something we haven't really touched on is polarization index, so PI. What is that kind of influence it has on IRT testing?
Sure. So everything I've been talking about so far has been what's called a spot test. So you just running a test to see if the installation is good or bad. There are tests such as the polarization index test that are more diagnostic in nature. It's not a pass-fail. It's more about the quality of the installation, and you're trying to determine, is it getting worse or is it getting better? So polarization index is very popular. A lot of people just say, PI test, do the PI test on the installation. And what they're actually doing is running an insulation resistance test, and the instrument normally automatically will take the resistance value after 1 minute of applying the test voltage and take another value at the 10-minute mark, and it divides the 10-minute value by the 1 minute value. That ratio or index gives you a measure of the quality of your insulation.
I see.
So if the ratio is less than 2, then that is bad insulation. Even if it passes the spot test, you would say this is bad insulation. Just from a diagnostic kind of look at it, you need to investigate it further. If the index value is between 2 to 9, then that is a good value, and you just want to track it over time, see how bad it's getting. If it's above 9, that usually means that the insulation's become very dry or brittle.
Yeah.
And then you got to take a look at that as well before it actually becomes a problem.
Yeah. So it's very important to kind of keep track of this as you go on your kind of insulation testing journey, so it can really affect the way you see your asset, I guess.
Absolutely. Because with insulation resistance testing, if you're just doing the resistance test just in one go, that is more like your pass-fail.
Yeah.
But if you want to really plan how you're going to manage your assets, when shall I replace something, or when shall I look to do some maintenance work on it, then it's important to do the diagnostic type of tests and track those over time, and they can give you really good hints over, what should I do with this asset, or how should I manage this asset?
Yeah. So it sounds like there's a lot more to insulation resistance testing than actually I think people first give credit for, right?
Absolutely.
That being said, is there anywhere that, people can go, or any papers you could recommend or something like that so people could learn a bit more about this?
Yeah, absolutely. We at Megger have published an awful lot of stuff over the years. The one reference that, above all else, that I would recommend is a booklet called A Stitch in Time.
Okay.
You can find that on the Megger website. It goes into the theory, goes into practically how you do the testing. It goes quite deeply into the diagnostics of testing, not just polarization index, but a bunch of other different types of tests, including dielectric absorption ratio, dielectric discharge, ramp testing, step voltage testing. So I highly recommend that one. And also, if you want to take a look at particular testers and what they can do as just a practical example, there is a handheld tester from Megger called the MIT 2500. It's quite small form factor and tests with up to 2,500 volts of test voltage. It's a very impressive unit considering the size of it. And probably the most popular type of installation tester is the Megger's 5 kV tester, like the S1568. That's a really good product as well.
Sure. Well, thank you so much for coming in and talking about this. We could talk about this all day, but I will let you go. And thank you so much for coming in.
Thank you very much. Thank you for your time.
Thank you for watching, and thank you for listening.